This is topic 5.5, determining absolute value extrema from candidates. I'm just going to go ahead and sketch a little graph. The critical points that we determine from a function or a graph give us possibilities of finding a max or a min. And the ends of the interval, also known as the endpoints, give us other possibilities of finding a max or a min. So let me just draw a graph here that has some endpoints. We'll just kind of curve it up, and then we'll come down, and maybe have it look like that, something like that. And of course, as you can see, we have an end point here and an end point here. These are the endpoints of our interval. And you can also see we have a critical point and a critical point and a critical point. And here, of course, the first derivative is undefined, but it still identifies a critical point. So what is really important about this graph is that you can see that this endpoint right here is an absolute min. And this endpoint is not. It is a local max, but this is the important one right here, is that here our endpoint is an absolute min. So we're able to find our absolute extrema by taking a look at the critical points and also the endpoints. So candidates for absolute extrema on an interval are critical points and endpoints. So we do need to look at the y values. And choose the highest and the lowest. For your absolute extrema. Okay, so let's go ahead and give that a try. That didn't work out very good. Bring that up a little bit, maybe a little bit smaller. Okay. So let's go ahead and give this a try. We're going to be looking at the critical points and also the endpoints. In number 1, find the absolute maximum value and the absolute minimum value. So here's our absolute extreme values that we are looking for of this cubic function on this closed interval. So of course, we have to first check the endpoints. And then we need to check the critical points. And we'll look at their y values. We might as well go ahead and find f of negative 1/2 and f of 4. And you can do that in a calculator. And I'll go ahead and give those to you. I just plugged them into this function right here. So when I plugged negative 1/2 in, I got 0.125. And a decimal form is nice because we're going to be comparing high and low. And f of 4 is actually 17. Okay, so now we need to find the critical points so that we can find those y values. So coming over here and finding the critical points, I need to first find f prime of x, and that is 3x squared minus 6x. So we want to see where f prime of x is equal to 0 and where f prime of x is undefined. Now, since we have a polynomial, f prime is defined everywhere. So we'll be setting f prime of x equal to 0, and you can see that x is equal to 0 and x is equal to 2. So we're going to go ahead and find those y values, so f of 0 and f of 2. And I went ahead and did that for you, and f of 0 is 1 and f of 2 is -3. So we're going to be comparing these. We're looking for the highest y value. Maybe I'll just highlight the y value, and the lowest y value. And with that, we will now write our absolute extrema we have an absolute max, and in this question, they just wanted the value. They didn't ask where they were. So we have an absolute max of 17, and we have an absolute min of -3. So, and you could even, since they didn't want to know where, you could even say absolute max is and is. Okay? Now let's take a look at this graph of f prime. Again, we need to keep in mind what graph we're looking at. And we're going to see if we can identify relative extrema at the x-intercepts. Okay? We're going to be looking at the x-intercepts, and we're going to see if we can find the x-coordinate of the absolute max and the absolute min. So let's just say right here is the first part of the closed graph. So wherever that y value is on f, we begin to increase. So all of this area, every bit of this, let's see if I can shade this in, all of this is f prime is positive. That didn't show up very good there. And so this entire time we are increasing. Let's see if I can get a darker pen. So the graph f is increasing. That really didn't show up well either. So here f is increasing. So it is going to increase all the way until we get to x equal to 1. Now we don't know where the y values are, but it has been increasing. And it was increasing at the highest here, and that it's still increasing, all of these, okay? Those are the values of the slope of the tangent line to the curve. So you can see they started out a little bit and they became great, as steep, and then they weren't as much, but it is still increasing. And then now what do we see? We see this area here, and we're going to talk more about area under the curve, but this entire time f is decreasing. Our actual function is decreasing, and that's because the first derivative is negative. And then what happens? We go back to increasing again. So what we think happened is that we have here at x equal to 1, we have an absolute max. And the reason is that we were increasing. from x equal to -3 all the way to 1, and then we decreased, and you can see the area here, the amount in orange, and then we started increasing again. So here is the highest at x equal to 1. That was the highest that the y value ever reached. Okay. And that concludes this topic.